Today I will start trigonometry. I will start from De Moivres theorem as polar representation of complex number. You have already studied in your ACES classes. You can also go through my complex analysis video lecture 5. Here we will discuss De Moivres theorem with proof. First is the statement of the De Moivres theorem. De Moivres theorem. Whatever be the value of n positive, negative integral or fractional, we have cos theta plus I sin theta cos n theta I sin n theta. As per the statement of the De Moivres theorem, if n is any integer, positive, any number, positive, negative, integral or fractional, we have cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. Now we are going to prove this theorem in 3 cases. First for positive, second for negative, and third for fractional. Proof. Case 1. Case 1. When n is positive, consider the product cos theta 1 plus I sin theta 1, cos theta 2 plus I sin theta 2. Find out the product, expand this one, that is first product of this one with this, then with this. Write this cos theta 1, cos theta 2, then plus I cos theta 1 sin theta 2. Then again the product of this term with this one, this with this one. Then product of this with this one, that is plus I square sin theta 1 now I square is your minus 1. Now write real part with real part and imaginary part with imaginary part. Then this one is cos theta 1 sin theta 1, and this term sin theta 1 cos theta 2. So this is by using the formula cos A plus B A cos of P. If it is plus, then it is minus. If it is minus, then it is plus. So using this formula, here in place of A, I am taking theta 1, and in place of B, I am taking theta 2. In place of A, theta 1, theta 2. So this formula will be this cos theta 1 plus theta 2. Then again using this formula, so here use this formula for this part, you will get this. Next, again consider, we have to prove this one. So write this down. We are going to prove this. That is, this one is this. Write this. Now we are going to consider product of three terms. Okay, theta 1, theta 2, then theta 3. Now check out this product. Value of this product is by this one. So cos of theta 2 I sin theta 1 plus theta 2. Also theta 3 plus I sin theta 3. Write out this one. Cos theta 1 plus I sin theta 1. Cos theta 2 I sin theta. So again expand this one. You will get cos of theta 1 plus theta 2 cos of theta 3 plus I cos of theta 1 plus theta 2 sin theta 3. Then again this with this one. So I sin theta 1 theta 1 plus theta 2 again cos theta 3. Here it is I square I square. So this is minus 1 wrap this out. We will with the last, right? We will use this one. This is I sin theta. Sin theta 1 plus theta 2. So write the real part with real part and imaginary with imaginary part. Theta 1 plus theta 2 Again, use the formula cos A plus B formula. Here it is A, this B. Okay. So here it is cos A is theta 1 plus theta 2 plus B, that is theta 3. Okay. Again, use here sin A plus B formula. Here A is this one and B is this one. Okay. So this is sin theta 1 plus theta 2 plus theta 3. Okay. That means if I consider 2, then my result is cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. If I consider 3, then I will get cos theta 1 plus theta 2 plus theta 3 sin theta 1 plus theta 2 theta 3. Proceeding in this way, we get cos theta 1 I sin theta 1. Cos theta 2 plus I sin theta 2. Cos theta n plus I sin theta n. Okay. Proceeding similarly, I will get the value as cos theta 1. If 2, then I will get here theta 1, theta 2. If I consider 2 up to here, then I will get up to here. If I consider 3, I will get sum of 3 thetas, theta 1, theta 2, theta 3. So here I have considered product of n number of thetas. So I will get sum of n number of thetas. Next, if theta 1 is equal to theta 2 up to theta n, and it is equal to theta. That means all the theta i's are equal. I ranges from 1 to n. It is equal to theta. Then in the left hand side, you will get cos theta plus I sin theta into cos theta plus I sin theta. How many times? N times. Okay. 1, 2 up to n times. In the right hand side, I will get cos theta plus theta, sum of how many thetas? N times. Plus I sin theta plus theta n times. Here, this implies cos theta plus I sin theta to the power n, and in the right hand side it is cos n theta plus I sin n theta. Okay. Hence, the result is proved when n is positive. We will get this result when for the first case, that is when n is positive. Now, I am going to prove the result for when n is negative. Case 2, when n is negative. Let n is equal to minus n, where n is a positive number, positive integer. Now, consider this one. Cos theta plus I sin theta and cos theta plus I sin theta to the power n. If I replace n by minus m, then I have replaced here n by minus m. Here m is my positive number. Here it is minus in power, so I can write this as this one. Okay. Okay. Now by the first case, where here m is positive, so by first case I will get this one m theta m theta. Okay. This is by first case. By case one. Now make the denominator free of I. For that you have to multiply it by its complex conjugate. Complex conjugate you have already learned in your SS classes. If you have any problem, you can go through my complex analysis video. First 10 videos are on basics. You should go through that video. You will get the method. So to make this free of I, you have to multiply this number by its conjugate, that is nothing sin and theta. I am writing in the upward. To make the denominator free of I, have multiplied this by its complex conjugate. Complex conjugate is nothing. You should replace I by minus I. Okay. Then here in the numerator it is this one, and in the denominator it is a plus b. It is a minus b. So it is a square. If this is a and this whole is b, this is a, this whole is b, this is a minus b, a plus b. So this is equal to a square minus b square. Here a square is cos square m theta minus, here it is I square. I square is minus 1, so plus 1. This is sine square m theta. In the denominator it is 1, and in the numerator it is next. We know that cos is an even function. If cos is an even function, then we can write cos minus theta is equal to cos theta. Sine minus theta is equal to minus sine theta. This is minus m theta. This is plus I. I am bringing this minus to here. This is minus m theta. This is minus m theta. In place of minus m, I can write m. This is m. So I am writing m. Writing m theta I sine n theta. Okay. have got the result. We have taken this one, we get this. That means I get this result when n is my negative integer. Now, before going to prove the third case, we will prove one result. That is, if n is positive, if n is positive, if n is positive, then find out what is the value of this one. Then value of this one by using first case, since n is positive, by first case I can write this cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. So using this result, I will get this. So here, if I take 1 by nth root, 1 by nth root of this one, I will get this. Okay. I will use this result when I will prove the third case, that is cos theta plus I sin theta to the power 1 by n is cos theta by n plus I sin theta by n. Now I am going to prove the third case. When n is fraction, let n will be in the form n is fraction, so n is equal to some p by q with denominator not equal to 0. Now we are going to find out this thing. Okay, so this is equal to cos theta by I sin theta in place of n. I am putting this value p by q. Now I can write this one by using the law of exponentiation. By using law of exponential, I can write this. Okay. Now by first case, I can write this one when n is positive. This is positive or negative. P is either positive or negative. From case 1 and 2, I can write this value. Okay. 1 by q. Again from this result, if I replace n by q, then I will write this as this one. P theta by q plus I sin P theta by q. And in place of P by Q, I am writing n. This hence the result, that is, I have considered this one cos theta plus I sin theta to the power n. I am getting a cos n theta plus I sin n theta for when n is fraction. N is fraction. So we have got the result for when n is positive, then we have got the result when n is negative, and we have got the result when n is fraction. So this is de Moivre's theorem. In the next video, we will discuss some example on de Moivre's theorem. With that, I would like to conclude. Remaining will be in the next video.